All right, so now we're going to continue section B, rational equations. Remember that means fractions. But now we're going to solve using our LCM, right? And our LCM is our least common multiple, right? So when we are going to use this is whenever we don't just have a fraction equal to a fraction. So whenever we had 2 over 3 is equal to 2 over x. Well, whenever we just have two fractions equal to each other, then we use cross multiplying. But if I gave you this example and I said 2 over 3 is equal to 2 over x plus 1, it's no longer just two fractions equal to each other, so we will then need to solve by using our LCM or our least common multiple. All right, so let's talk about first how we find our least common multiple and then how we would use it. All right, so if I give you two numbers, 2 and 9, and I ask you to find their least common multiple, what you're trying to actually solve for is what is the smallest number that they both multiply into. All right, so we can go ahead, we can say 2, 4. So then what we're going to do is we're going to list all the multiples of 2. So 2 goes into 4, we can go into 6, 8, 10, 12, 14, 16, 18, 20, and so on. And then we look and we list the multiples of the next number. So we can do 9, 18, 27, 36, 45, and dot, dot, dot. And then we look and see, do they share any of the same multiples? Well, I see that 2 goes into 18, and so does 9. So that means our least common multiple between these two numbers would be 18. Right? And if you notice, you could do 2 times 9, and it gives you 18. But let me show you an example where that does not work. Let's do 2 and 6. Right? If we just multiply these two together and think our least common multiple is 12, let's see if that's true. Well, 2, we have the multiples of 2 are 2, 4, 6, 8, 10, 12. Dot, dot, dot. Right? For 6, we have 6, we have 12, dot, dot, dot. However, although they both go into 12, the least common multiple in this case is 6. So we're looking for the smallest number that they both can divide evenly into. So in this example, our least common multiple would be 6. All right, so this is something you have to be able to figure out or find when you're given multiple numbers, right? Is you must figure out the smallest number that they divide into or that they can multiply into. If you do just multiply your two values together and say your least common multiple is 12, you can still answer the question, but it's just going to mean that you're going to be dealing with larger numbers, and since you can't use a calculator, that can make things a little bit more tricky. All right, so our least common multiples when we're given two numbers is the smallest number that they both multiply into. And you can list them out like I did here, or if you're given two values, like if you're given, let's just say 3 and you're given 12, and you're looking at these two numbers. Rather than list them out, well, I know 3 divides evenly into 12, so that's going to be my least common multiple between these. And if I have 4 and I have 6, well, I know 4 goes into 12 and so does 6, so that means that's going to be my least common multiple. So you don't necessarily have to list these out, but if you can't figure it out just looking at it, then you might have to. All right? And the other example I wanted to go through with you guys is what happens if you have a variable and a number. So if I have 4 and I have x, it's impossible for me to list all the multiples of x. So it's impossible for me to see what is actually the smallest number for it to go into. So whenever you do have a variable, you simply just multiply them together. So our least common multiple between 4 and x is 4 times x. All right, same thing if I gave you 5 and x plus 2. You would simply just multiply these together. Anytime you're trying to find the least common multiple and it includes a variable, you would multiply them two together. The difference is here, you would distribute the 5 in, so our least common multiple, you can say is 5x plus 10, or actually for today, you'll see you do just leave these separately. You don't actually multiply them in. All right, so this is something you have to be able to do and understand. When we have numbers, we list them out, or we can identify which ones are least common, and if it includes a variable, we do just simply multiply them together, and that is our LCM. All right, now let me show you how we use this to solve problems. All right, the first example we have here, x minus 3, or x divided by 3 minus 1 minus 2x over 6 is equal to negative 4. We do not just have two fractions equal to each other. So we cannot just cross multiply. So when this happens, we identify all of our denominators, 3 and 6. And we find the least common multiple between those denominators. Well, since 3 goes into 6, our least common multiple is 6. right? And then from here, what we have to do, let me just pause this for a second. From here, what we have to do is we need to multiply every single fraction, or actually every single term on both sides of our equation. Everything will get multiplied by our least common multiple. So we multiply this by 6, we multiply this by 6, and we multiply this by 6. When we do that, 3 goes into 6 2 times, so we're left with 2x. These two 6's cancel, so now we're left with minus 1 minus 2x. I'll explain why I put that in parentheses in a second. And then 6 times negative 4 is equal to minus 24. By doing that, do we have any fractions anymore? No. So when we multiply by our least common multiple, it clears out our fractions. Right? The reason why I put this in parentheses is anytime you have multiple terms following a negative sign, both of them need to be subtracted. So you must put that in parentheses. We will then distribute the negative sign in. So this actually becomes 2x minus 1 plus 2x is then equal to negative 24. All right, we can then combine our like terms of 2x and 2x. So that gives me 4x minus 1 is equal to negative 24. And then from here, we can go ahead and we can start isolating our variables. So we can add 1 to both sides. So we get 4x is equal to negative 23. And then we can divide each side by 4. And that gives me x is equal to negative 23 over 4. All right, and that will be our final answer. We can substitute it in to check to see if it's correct if we want, but you do not have to. All right, now the next example we're going to go through is what happens when we have a variable in our denominator. Once we see we have multiple fractions and we can't just cross multiply, we highlight our denominators and we look for our LCM. Well, remember, when we're trying to find an LCM that includes a variable, we simply just multiply them together. So this is actually our LCM. You don't actually need to distribute the 2 in, and I'll explain why in a second. Leave them separate. So we will multiply everything by 2 times x plus 3. Every single term gets multiplied by that. 2 times x plus 3. And this gets multiplied by 2 times x plus 3. All right, and now, because we don't actually multiply it through, you see, this 2 just cancels out with this 2. So whenever we do have a variable in our denominator, it will usually cancel out one of them every time we go. So then we will do x plus 3 times 1. In this case, the x plus 3 will cancel out the x plus 3, so we're left with x times 20. And then in this case, there's no denominator, so there's nothing that we will cancel out. So I'm just going to leave it together. It'll be 3 times 2 times x plus 3. And we'll just do it step by step. All right, you can multiply this all through in one case if you want to. But 1 times anything is whatever we're multiplying it by, so it's x plus 3. X times 20 is going to be 20x. In this case, we have 3 times 2, which is 6, and then that will be distributed into the x and the 3, so it's equal to 6x plus 18. All right, now we will combine all of our like terms. So we have 21x plus 3 is equal to 6x plus 18. And now that we have variables on both sides, we need to go ahead and simplify this. So I'm going to go ahead and move 6x to both sides. So that will then give me 15x plus 3 is equal to 18. I will subtract 3 from both sides. So 15x is now equal to 15. And then we divide each side by 15 to isolate our x. We're doing our inverse operations. So that then gives me that x is equal to 1. All right, and if you want to check your work, you can plug it back into the original equation. All right, we have one more question, and then we're done with this section. Actually, I'm going to go through both of these. All right, so for this one, we don't have a fraction equal to each other, but since these are both whole numbers, what we can do for this is we can just rewrite this and isolate that fraction. So rather than finding our LCM for this, we can just add 3 to both sides, and we get x over 5 is then equal to 2. And now we actually have x divided by 5. Well, what is the inverse operation of division? It is multiplication. So then we multiply 5 to both sides, and we get x is then equal to 10. Right? So when there's no variable like the ones that we were doing before in our second term, we can just add it or subtract it to the other side. It's fine, and then we can just cross multiply. And the difference between this problem here, let me erase this for a second. The difference between this problem here and the one that we have next is this is being separated by a subtraction. This is being multiplied. So this one we had to add it over here. We could just get rid of this 1 over 5 because it's being multiplied to our variable. And then we will multiply. It's essentially being divided by 5, but whenever you're being multiplied by a fraction, you multiply by its reciprocal. And remember, you say you love me, now you're flipping like reciprocal. So we'll multiply each side by 5, and that will cancel out the 1 over 5. And now we're left with x minus 3 is equal to negative 5. And now we don't even have fractions anymore. We can just add 3 to both sides, and we get x is equal to negative 2. Right? So these last two examples are actually a little bit easier than the ones that we were just doing. And it's actually from section A, which is why they're a little bit easier. But I didn't want to do the fractions in section A and then fractions now. I'd rather wait and just do them all together at once. All right, so let's go ahead and end the video here.